Welcome to part 4 of 4 on Introduction to Trig Functions and Identities. In this video, we're going to look at area of a triangle. Do you remember the formula for the area of a triangle way back from maybe a geometry class or even maybe a pre-algebra class? Suppose we know the length of two sides and the angle they have. How might you express the height with respect to the given information? We have two triangles here where we have sides A and B that both share the same vertex, and an angle is formed between them. In both these cases, we can use a formula that's a little more robust than 1/2 base times height, because now we have trig. And we can talk about the definition for the area of a triangle in a little more precise a way. The area A of a triangle with angle theta and with sides of length A and B, respectively, as initial and terminal rays of the angle can be given by A is equal to 1/2 A times B times the sine of theta. And this is really cool because you can use this for any triangle as long as you have that angle. And in fact, if you had the area, you could find the angle. We'll talk about that later on in the quarter. But let's take this information that we know and this formula that we have, which you should memorize, so go ahead and highlight it. And let's see if we can find the area of the triangle that has an angle 135 degrees with the corresponding sides of 12 meters and 20 meters, round to the nearest whole number. Let's see if we can sketch an approximation for this example of 135 degrees. That means that it's an obtuse angle, 135 degrees, with sides corresponding 12 and 20 meters. We'll call this 20 meters. And this 12 meters. And then I'll go ahead and connect these two rays. So my triangle is going to look something like this. And I want to fill this in because remember, I'm finding the area of this triangle. The area is equal to 1/2. A, we'll call A 12. And we'll call B 20. We'll put the little meter units in there. And then we'll multiply that by sine of 135 degrees. Can you guess what I'm going to tell you next? Don't forget to put it in degree mode. Put your calculator in degree mode and then see if you can find the area of the triangle. I'll go ahead and just put a decimal 0.5 times 12 times 20 times sine of 135. And I have 84.85 square meters. It says to round to the nearest whole number, so I'll go ahead and round it up to 85 square meters.